Welcome to EE World. I'm Senior Technical Editor Martin Rowe. In researching this article on using AI for automated test, most of the discussions have been about taking a large system and automating it, whether it's for a functional test or for a parametric test or whatever. But what about calibration? The way we calibrate most instruments is by putting in a known quantity. If it's an electrical quantity, you might use a multifunction calibrator, for example. And you connect your unit under test to your computer, and the computer software can read the data from your instrument. And it goes into your calibration record and then ultimately into a calibration report. But what if you have an instrument that doesn't have a computer port? For example, a simple basic handheld multimeter, or a torque wrench, or a mechanical caliper. These can all have digital displays. And yet the only way to put the data in is to record it yourself and put it into the calibration software manually. What if we could automate that? Well, Jeff Gust at Fluke Calibration is going to explain how the company is using AI to read the displays using a simple webcam or laptop camera. So Jeff, thank you for coming on. And can you tell us a little bit about this software and how it works?
There are certain calibrations that are really labor intensive and also can be prone to errors. And that's when you're dealing with the calibrations of instruments that are not interfaceable into computer systems. Things like that could be your typical handheld 3.5-digit multimeter. It could be torque wrenches. And the other category of that could be analog pressure gauges. And we wanted to come up with a tool that would make it easier to do calibrations of these devices. What the tool does is we have used a couple of different AI tools and engines to be able to quickly read and determine the display on any either digital instrument and also an analog instrument like a pressure gauge. What we wanted is to use AI to be able to look at any display at any time to be able to quickly come up with images for measurements for that model that could be metrological grade, if you will, of a very high accuracy.
So this tool uses a camera, I assume.
Yes.
And it is able to read the display. So take us through the steps that are involved here. And given that the unit under test is not connected to a computer.
You're right. The goal was to make this simple and affordable for customers as well. So we are just taking any type of a camera. We could be using the camera that you and I are using today for this interview as the tool for that, or any other type of webcam, and we connect it up to our system. And from that, we implement this. We start the software where it's integrated into some of our test devices, and we could either press the enter bar on the computer, or if we've got things set up correctly with it, we could also use a voice command to say capture image, and it will automatically capture the image. So if you've got both hands full, that you could say you're adjusting the instrument or you're looking at an instrument. A good example of that, say if you're doing a simple calibration of a micrometer with a gauge block, where you might be holding the gauge block in one hand and the micrometer in the other, and you want to capture the image off of the micrometer, you could just say capture the image, and it records the image, and it'll plug it right into the calibration worksheet for you.
So it will actually read the numbers from either from an analog dial or from a digital display and put it directly into a sheet, into
Yes.
an electronic sheet. And
Yes.
Okay, and so from that, you can then look at the reading, compare it to what you expect. Is it within range? And if it's if it, even if it is, by how close to the edge it might be, and if it's out of range, it'll certainly tell you that as well. So what kind of a report do you get from doing this?
What we've done right now, the first tool that we've integrated this in is into a tool called Qubit we developed at Fluke. But we've also integrated it into our MetCal tools as well, and we'll be offering that to customers fairly soon. You've been using the same MetCal automated calibration system. Now this will just be a button that you can push to say, now would you like to automate these measurements using OptiCal, and it'll automatically plug in with no extra code and just be a nice tool for people to use. I do think that I have a demonstration set up for OptiCal if we want to give that a try here today. Okay, so this is our website called Qubit, and it's at qubit.io, and it is the first thing is a note is that the goal of this website is to be able to have every single piece of test equipment eventually stored here so that you could look at the specifications for. You can see we have 748,624 data sheets for different types of products, in this as well. So if I wanted to do a quick search, for example, for torque wrenches, and I'm just going to grab the first one, a BMS torque wrench, and it's got different calibration methods. There's 3 different auto-generated methods that are based. So these are the specifications for it. And it's 0 to 600 Newton meters with an accuracy of plus or minus 1%. And so again, if I go back to this and I want to pick one of these, you can see I could either set up a calibration where it automatically creates a data sheet that I just enter in the data, or I have the option of calibrating now using OptiCal. So I'm going to go ahead and do that. And you'll notice it brings up a camera screen. The camera is currently disabled. And down here, you can see where it's taking the readings. And on this particular calibration, it's asking you to take 3 readings at each test point, and then it averages out the results of those readings. So I'm going to go ahead and just say, let's go ahead and run. And if you notice that now we've got a screen that's popped up. And I don't have a torque wrench, so I'm just sitting here in my office. But if we see that we're looking for 300 Newton meters, so I'm just going to use my calculator for fun. Let's make a 301.5 as a display. And I've got to put this up in front of my camera, get it to kind of focus a little bit. And I'll say capture. And you can see that it just said it's 30. It recorded that as 301.5. And the nice part of this is as well is that you've got a photograph record of the measurement. So, if you were worried, hey, if you were manually keying this in, you said, oh, did I key that in correctly? Oh, well, you can go back and take a look at the picture. Or if you're worried, well, did the AI technology capture my image properly? Well, now you've got evidence of the actual data point. And in metrology, we call that original observations. And if I want to make it fail, let's call it let's make it 258.3. Well, you can even see I'm going to be crooked and off screen. And we get 258.3.
So now that you have this data, you usually need to produce a calibration report. Now, what happens from there? Is that something that, does MetCal pick it up and take it from there? How does that work?
Exactly. It just pulls, now that it's in data form, we can pull it into any calibration report format that we want. So we can produce a certificate in Qubit itself, or we could port it over to MetCal and be able to record all this history as a part of the calibration record.
So in terms of analog meters, it could also be in terms of an analog voltmeter. That's something you still
Yes.
That's sort of the next step.
Yes. Yep.
Okay.
It will read analog panel meters because they have an arcing display, and our AI can pick up and measure the low point and the high point, and calculate the degrees of arc, and be able to read the scale from that.
Now, how do you train the AI to know how to read let's start with reading the digits. How much does it take to train the AI to get it to be reasonably accurate?
So that actually took months and months of work, where we came up with a metric about image quality and image accuracy, its ability to measure, to give us the correct value from any image that was being captured. And so we tracked that, and I think we started for analog gauges, I think one particular gauge we started with about 40% accuracy, and now we have it to where you could put any model of analog gauge up to it, and you're over in the 95% accuracy, plus 95 to 99% accuracy. We had to build up the training database, and it wasn't just for one gauge, but any gauge. AI tools became more and more available. So for a couple of times, we actually hit the wall of saying, we're not going to be able to make this more accurate with this generation of AI technology that's available to us. And we had to wait until the next generation came out, and then we saw an increase in that capability once again. It took a lot of hours, a lot of work, researching different AI technologies, and some tricks that we've came along the way that we're in the process of patenting as well.
Jeff Gust of Fluke Calibration, thanks for speaking with us today. For EE World, I'm Martin Rowe. Thank you for watching.